Hello everyone, this revision test is designed to help you recall, connect and apply your understanding of 3D geometry from cylinder and cones to spheres and hemispheres. Take this as your quick challenge before the main exam. In question number 1, volume of cone is given, its height is given, and you need to find diameter of its base. So let's start with the given information. Volume of cone is 1 by 3 pi r square h. Replace volume of cone by 48 pi is equal to 1 by 3 pi r square h. Now cancel this pi and pi. Substitute the value. Since h is given 1 by 3, r square h is 9. Again we can cancel 3 and 9. Send everything to other side. 48 upon 3 is equal to r square. 3 and 48 cancel, 16. So r square is 16, which means r is equal to 4 centimeter. And diameter is double of radius, hence 8. Question number 3. A cone, hemisphere and a cylinder stand on equal bases and have same height. Find the ratio of their volumes. So write the volumes of these solids in the order given. Volume of cone is 1 by 3 pi r square h. Hemisphere 2 by 3 pi r cube. Cylinder pi r square h. Now in hemisphere, radius and height both are same. So whatever is same, first cancel it out. Pi is common in all three. Now replace hemisphere 1r as h and write it again. So we have r square common in all three volumes, h, h and h. You will be left with 2 by 3, 1 by 3 and 1. Multiply by 3 as the denominators are 3. So multiply each by 3. So your final ratio will be 3 by 3, 6 by 3 and 3. This implies 1:2:3. Question number 4. How many spherical balls can be made of a cylinder which is 28 meter high and radius 6 centimeter if each ball is 1.5 centimeter in diameter? First, convert this diameter into radius by dividing it with 2. Now change this decimal number into a fraction by removing this decimal and putting 0 in the denominator. Both are divisible by 5. So this is reduced to 3 by 4. So whenever we are finding number of chocolates, number of pens, number of balls, we use division operation. So in the numerator, write the bigger one, volume of cylinder. because we are creating small spherical balls out of it upon volume of one spherical ball. Write the volume. First write the formulas. Pi capital R square, as we have two solids, so both should be distinguished by different R's, and in denominator 4 by 3 pi small r cube. Now whatever is same, first cancel it. So it pi is common in both, so cancel pi. Next replace all with its original numbers. 28 into 6 into 6, r square is 6 into 6 height, 4 by 3 pi is already cancelled, r cube will be 3 by 4 into 3 by 4 into 3 by 4. Again we can cancel these 3 and 4. Now in the denominator we have fraction, so we will use concept of reciprocal multiplicative inverse. This will become 4 by 3, 4 by 3. Again there's a possibility of cancellation, 3 and 6, here 3 and 6. So we are left with 28 into 2 into 2 into 4 into 4. So the final answer is 1792. Question number 5. A cylindrical road roller 2.5 meter in length, 1.75 meter in radius, when rolled on a road was found to cover the area of 5500 square meter. How many revolutions did it make? Now what is this 5500? It is curved surface area 5500, because while leveling the road, this road roller is only using the curved surface area of this cylinder. Now here length is given as 2.5 meter, which is same as height of a cylinder. Radius is given as 1.5 meter. Again we are finding the number of revolutions, so we will use division operation, which will be total area upon CSA of cylinder. Total area is 5500. Use the formula 2 pi RH. Replace it by the original numbers. 5500 upon 2 into 22 by 7. R is 1.75. So 175 upon 100 into H is same as length. So 25 upon 10. Converting all decimal number into fractions. Now whatever cutting is possible, cancel it. 7 and 175 can be cancelled. 7, 25, 25 and 100 will be cancelled. 4, 4 and 2 will be cancelled. 1, 2 and 22 will be cancelled. 11. Now this 25 and 10 will be cancelled. 2. This 11 and 55 will be cancelled. 500. Now this 5 and 500 will be cancelled. We will be left with 100 upon 1 by 2. Again we will use concept of reciprocal multiplicative inverse. So this will be 2 by 1. So the final answer is how many revolutions? 200 revolutions. Question number 6. A shopkeeper has one big spherical laddu which is 5 centimeter. With the same amount of material, how many small laddus of radius 2.5 can be made? So there are two sizes. One is bigger, which is radius as 5 centimeter, and other one is smaller. So we are using small r, which is 2.5. Change this into a fractional number, 25 5 by 2. Again, we are finding how many laddus, so we'll be using division operation. Number of laddus will be volume of bigger upon bigger laddu upon volume of smaller laddu. Write the formula. 4 by 3 pi r cube will be 5 into 5 into 5 upon 4 by 3 pi. This will be 5 by 2 into 5 by 2 into 5 by 2. 4 by 3 and pi is common in both the cases. 5 into 5 into, now find the multiplicative inverse of denominator. It will be 2 by 5 into 2 by 5 into 2 by 5. Cancel the common numbers. 2 into 2 into 2 is 8. So how many laddus of radius 2.5 can be made is 8 laddus. Thank you and happy learning.